Continue with 7.4, game theory part 1 here. Three-finger Mora is similar, except now we're going to have 3 choices for each player. And the payoff, I guess, is going to be the player 2 is going to pay player 1 the difference between the fingers shown. So the payoff is going to be player 1 minus player 2. That's the payoff. So 1 minus 1, see, player 1 minus player 2. 1 minus 1 is 0. 2 minus 2 is 0, and 3 minus 3 is 0. So if they show the same fingers, 1, 2, or 3, that's the 1, 2, or 3, right? Then they don't win anything. It's a push. So 1 minus 2, though, is a negative 1. And 1 minus 3 is a negative 2. So here, really, player 2 is winning. 2 minus 3 is a negative 1. And similarly, 2 minus 1, 3 minus 1 is 2, and 3 minus 2 is 1. So this is the payoff. What is the strategy? What should they do? Because they get to choose the fingers that they are going to show. Well, we'll look at that minimum value here. For this row, it's negative 2. For this row, it's negative 1. And for this row, it's 0. The maximum value for the columns, the maximum is 2. The maximum here is 1. And the maximum is 0. And we want then the maximin, the maximum of the minimums, that's this, and the minimax. The smallest of the maximums, that's this. So once again, this strategy is pretty straightforward. What is the best strategy for player 1? They should always choose 3 fingers. And for player 2, they should always choose 3 fingers. So this one is also a fair game because the saddle point is 0. Nobody's got an undue amount of, I guess, winning coming towards them. So the value of the game is 0. It's a fair game. It is strictly determined because this saddle point is the same for each row and column. So all of these have been strictly determined so far. But that's not certainly always the case. If we try to take a look at some of these so let's look at a few other examples, not going through all of the 3-finger Mora explanation at all. Let's assume that we have this payoff matrix. Let's see, 1, negative 2, negative 3, 2, 4, and 1, and negative 3, negative 4, and negative 2. This is player 1 and player 2. And we don't know exactly how they determined this, but that's not the point here. We want to figure out, if this were the matrix, what would we use as far as our strategies are concerned? So we, once again, take the minimum values for each row. This is negative 3, this is 1, this is negative 3. The maximum values for each column. The maximum here is 2. The maximum here is 4. And the maximum here is 1, right? And then for the combination, the maxi-min, the maximum value of all the mins is this. The mini-max, the minimum value is this. So once again, this is strictly determined. This is the value of the game, 1. Since it's not 0, it's not a fair game. But the strategy would then be whatever this row would give you for 1 and whatever this column would give you for player number 2. Let's look at another one. Assume you've got this matrix, 2, 1, negative 3, negative 2, 0, and 2, and 3, negative 1, and 1. The minimums, negative 3, negative 2, negative 1. The maximums, three, 1, and 2. The maxi-mins, that would be the negative 1 here, and the minimax, the smallest, would be the positive one. Aha! This is not strictly determined because the saddle points are different. We could have different strategies then to try to figure this stuff out. That could happen where you have different values for each of these rows and columns. Another example, assume we have this payoff matrix. The minimum values for the rows. This is a negative 2. This one is 3. This was a negative 1, and this one is 3. The maximum values for the columns. This is 3. This is 5. This is 3. And this is 6. The maxi-min, now we got 2 choices here. And the mini-max, we got 2 choices here. This one's strictly determined, but now we've got 2 choices that we can make. And we might have to do some more thinking to see if this mixed strategy is going to be helpful for us winning the games. So, it could be strictly determined. Anytime those saddle points are the same, so is it strictly determined. You do the same thing each time. Those kind of games aren't so fun because that's, once you know the strategy, then it becomes just an automatic thing. Sort of like when you're playing tic-tac-toe, you know the strategy. But if you've got a mixed strategy, then if you want to throw a curve to it, you might be able to, maybe not. But that's coming up in section 7.5. We'll see what happens.